Hi there, and welcome to an experiment I've been doing on synchronizing four Sonic Pi machines together. Here I've got my MacBook Pro, which is the master machine, and you can see that we have a live loop here which is going to send out sync pulses to three separate IP addresses, and these correspond to three machines which I've got running as well of different types. Over here I have a Raspberry Pi which is running on a Pi-Sound, and that is waiting here to sync to sync 2, and you can see it's a live loop there, and you'll notice also there's a time warp around the second section of that, and that is because all of these machines have got slightly different audio latencies because they've got different audio systems. This one has got a Pi-Sound card for its audio, and over here I've got a knackered old iMac. You can see that the screen is a bit shot, but I've actually reconfigured it to run Sonic Pi and Linux. It's actually running Ubuntu, and that is running the identical program here, but that's going to sync to the OSC sync signal, and that has a slightly different time warp setting of 0.18 opposed to the time setting over here. In fact, this one's the same. These two are pretty well in sync with each other. However, when we come over to the final machine, which is a Pi-Top Seed, and that has got the Pulse audio card fitted to it, which is actually running a Hi-Fi Berry DAC, and that appears to have a slightly different time lag, and so there's no time warp on this. This is running as soon as it can get the sync signal, and it's going to play the scales here, the E5 minor pentatonic scale. This one is going to play E4 minor pentatonic, and this one is going to play E3 pentatonic. I'm going to start this off setting a BPM of 20. That's recorded in using a set BPM signal there, because down here it's going to be retrieved. BPM equals get BPM, and it's going to send that as a parameter with the sync signals. So I'm going to start the Mac running here, which we'll do. The others are already running and waiting, and you should hear them start off together, three separate tones. You could see the three sets of OSC signals being sent out to do the sync, and you can see this one running here. This is actually producing the low tone. I've just turned it up so you can hear that. We'll turn it down again a bit. This one is running the middle tone, and in fact in this case there's no volume control. We've got to just use the volume setting here. If I take it out, you can hear it disappear. And that's running the middle tone, and over here we're running the top tone. And you can hear they're pretty well in sync. I could play a bit around more maybe with the time warps to adjust them for the audio latency. The OSC signals are actually pretty well spot on. There's no problem with those. Let's now make things a bit more interesting. I'm going to uncomment here a bit of code which is going to adjust the BPM signals in a live loop called speed, and if we rerun this it'll pick that up and hear what happens. So you can see that these three machines here, here and here are running perfectly synchronized together, all receiving control signals from the central Sonic Pi, which is running on my MacBook Pro. So I think you can see that with a little bit of playing around, it's going to be possible to synchronize Macs together, Sonic Pis together. I haven't actually found out whether you can get a broadcast OSC to work, in which case you'd only have to send one sync pulse here, but it doesn't seem to matter. It's fast enough for three machines to be synced into the main one there, and I think probably you could get up to 7 or 8 without too much problems. So we'll stop that playing, which you can do simply by stopping the pulses coming there. They all stop in mid-scream, and of course I could restart them again, so they follow the conductor perfectly. Hope you've enjoyed the video, and I will publish the code in thread on Sonic Pi net, and you'll be able to try it out yourself there. Thanks for watching.